Hello and welcome back to a quick Calculus 1 tutorial problem here about solving an initial value problem using antiderivatives and indefinite integration. Alright, so let's get started off on finding our function of t, given our second derivative of t, our first derivative at time 0, and our function at time 0. Alright, so let's begin. We know that our first derivative here at t is going to be equal to the integral of the second derivative. Right? Let me write that in a different color here. Of our second derivative, which is cosine of t, with respect to t, right? Times dt. Times the differential t. So f prime of t is equal to the antiderivative of this. The way you can think about this in an easier way is what something, if you take the derivative of something, what something gives you that cosine value here in the integral. It's sine, right? Derivative of sine gives you cosine. So let's write that in. So sine of t. And then we're going to add this constant over here, constant 1, because no matter any numerical value you have that doesn't have a variable attached to it, that could be 10, 1, or 1000, right? It could be any number under the rainbow. The derivative of all of these goes to 0, right? So when you add this c here, you're kind of undoing that process that the derivative does by hiding this, right? Because when you take the derivative, d by dx of 10, that goes to 0. So when you take the integral of whatever else was in this function here, that 10 is hidden. So we add that in with our constant of integration, represented by c. It's really important, don't forget that. You will lose marks if you don't have that on your in your work. All right, we know something else here about the first derivative. We know that the first derivative at time is 0. At time 0 is equal to 3. But we know that f of t is equal to this. So we can set those two values equal. Sine at time 0 plus some constant 1. We're doing this to solve for this constant, by the way. So we know that 3 is going to stay the same, obviously. And then if you go into your calculator on radians and type in sine of 0, you will get 0. Use rad. Because we're dealing with trig here, right? So use radians. 0 plus c. So it's very easy to see here that c1 is going to be equal to 3. So let's rewrite our first derivative here as f of t is equal to sine of t plus 3. See what I mean? There we go. There's our unveiled c value. Because when you take the derivative of this, you simply get cosine. So adding this c in here helps us find this 3 that would have otherwise been hidden. All right, so now let's take the integral of our first derivative to find our base function, which I will use blue for. F of x, or f of t rather, sorry, is going to be equal to the integral of our derivative here, which is sine of t plus 3 with respect to t. And we're going to think it through in the same way we thought the last one through. Take the derivative of something gives you sine. What is that something? It's negative cosine, right? So you can say here, if I use black, that negative cosine of t plus 3, but it's not just going to be a 3, it's going to be a 3t. Thinking it through the same way we thought through the last one, take the derivative of something. What something is going to give you 3 rather. That something was 3t. Take the derivative of 3t, you get 3. Take the derivative of negative cosine, you get sine. Take the derivative of sine, you get cos, right? And then we're also going to add our constant of integration here. We'll call it c2. this is all equal to f of t. And we know something fun here. We know that f at time equals 0, or when t equals 0, is going to be equal to 5, as I have it written there. And that is going to be equal to this at time equals 0. So let's rewrite that here. We've got negative cosine at time 0 plus 3 times 0 plus c2. Right? So now let's work through this and simplify it. We know that cosine of 0 is simply 1, so negative of cosine of 0 is going to be negative 1. So 5 is equal to negative 1 plus 3 times 0, which is 0, plus c2. And now we simply solve for c2. It's very obvious that if we move this over here, c2 is equal to 6. So now we have all of our information here to find f of t. I'm going to clear up some space. And we're going to move up to here now. So we know that our function is going to be negative cosine at t, some t, plus 3 at some t, plus that constant that we just found, which we're going to say is 6. And that's going to be our final answer for this initial value problem. I hope this was helpful. Drop any comments you have, and I'll try